Beyond Neptune lies a silent, frozen frontier. This is the domain of trans-Neptunian objects, the final, unexplored puzzle pieces of our solar system. By the end of this journey, you will know the 25 strangest of these distant worlds, each one a story written in ice and shadow. We will encounter planets that spin so fast they stretch into eggs, rings that defy the laws of physics, and lonely wanderers on orbits so vast they hint at a hidden giant. What secrets do these icy fossils hold about the chaotic birth of our cosmic neighborhood? The answers are stranger than fiction. What do you picture when you think of the edge of our solar system? Our journey begins with a world of profound solitude. Sedna is not merely far away, it is cosmically isolated, a lonely wanderer on a path that seems to defy explanation. Discovered in 2003, this reddish object revealed an orbit unlike any seen before. Its journey around the Sun is a staggering ellipse, so stretched out that at its closest approach, it is still twice as far as Neptune. Then it recedes, drifting into the deep freeze for an 11,000-year-long orbit, reaching an almost unimaginable distance of over 900 astronomical units from the Sun. At that farthest point, our star would be nothing but an exceptionally bright star in its black sky. The mystery is not just its distance, but how it got there. Neptune's gravity, which sculpted the orbits of so many other objects, simply cannot reach Sedna. Its path exists in a gravitational no-man's land. So what colossal event could have hurled this world onto such a solitary track? Scientists are left with tantalizing and dramatic possibilities. Perhaps a rogue star passed terrifyingly close to our young solar system, its gravity plucking Sedna and flinging it outward. Or maybe it is an alien capture, a world that originally formed around another star and was stolen by the Sun's gravity. Some even speculate it could be evidence of a hidden, massive planet far beyond Pluto, whose unseen hand still guides these distant orbits. Sedna's deep red color, likely from a surface baked by eons of cosmic radiation into a complex organic sludge, only adds to its otherworldly aura. It stands as a sentinel at the frontier, the first clue that the story of our solar system's formation is far wilder than we ever imagined. Sedna's lonely path hints at a violent past, but the next discovery would shake the very foundations of our solar system's family portrait. In 2005, astronomers found Eris, a world so significant it forced us to rewrite the textbooks. Initially nicknamed Xena, this distant object was measured to be nearly identical in size to Pluto, and for a brief, exciting moment, it seemed we had discovered a 10th planet. But that excitement quickly turned into a profound dilemma. If Eris was a planet, then what about the other similar-sized objects in its neighborhood, and where would the line be drawn? Astronomers faced a cosmic identity crisis. Eris itself is a fascinating world. It orbits the Sun on a highly tilted path far beyond Pluto in a region of scattered debris. Its surface is astonishingly bright, one of the most reflective objects in the entire solar system. This brilliant shine comes from a coat of nitrogen frost, a veneer of ice that suggests a complex and possibly active surface history. It even has a tiny moon, Dysnomia, which orbits it like a faithful companion. The existence of Eris and Dysnomia was the final straw. It proved that Pluto was not a unique oddity, but simply the largest known member of a vast crowd of icy worlds in the Kuiper Belt. The International Astronomical Union was forced to make a difficult but necessary decision. In 2006, they created a new definition for a planet, one that required an object to clear its orbital neighborhood of debris. Pluto, and by extension Eris, did not meet this criterion. They were reclassified as dwarf planets. Eris did not just join the club, it shattered the old one and prompted the creation of a new one. It was the catalyst that dethroned Pluto, not out of rivalry, but out of clarity, teaching us that our solar system is far more populous and diverse than we ever dreamed. The redefinition of planets was a scientific revolution, but the Kuiper Belt was just getting started with its surprises. Haumea shatters every expectation of what a distant, frozen world should be. This is not a slow, solemn sphere of ice. It is a cosmic egg, tumbling end over end through the void at a breathtaking speed. Haumea completes a full rotation in just 4 hours, a spin so violent it has stretched the entire world into a distinct ellipsoid shape, like a river rock smoothed by a relentless current. If you stood on its elongated surface, a day would flash by in a blur, with the horizon curling away in a dizzying, football-like curve. This frantic dance did not happen in isolation. Haumea is the matriarch of a celestial family. Astronomers have identified a collection of smaller icy bodies, all sharing similar orbits and a unique spectral signature, which are believed to be fragments from a colossal impact billions of years ago. This catastrophic event likely gave Haumea its incredible spin and also created its 2 tiny moons, Hioka and Namoka, which now dance around their wounded parent. But the strangeness runs deeper than its shape and its history. Haumea's surface is covered in pristine, crystalline water ice. This is a profound puzzle. At such vast distances from the sun's warmth, any ice on the surface should be amorphous, a glassy, disordered mess battered by cosmic radiation over eons. Crystalline ice is organized, structured, and it typically requires a source of heat to form or refresh it. So what could possibly be warming this frozen, spinning egg? The leading theory points to the energy of that ancient, shattering collision, or perhaps even lingering heat from radioactive elements in its core. This suggests Haumea, for all its distance, might have been geologically active in its past, or may even harbor a complex internal structure today. It is a world of violent origins and enduring mysteries, proving that even in the deepest freeze, the fires of creation still leave their mark. While Haumea's spin tells a story of violence, Makemake presents a different kind of mystery, one painted in a vivid and unexpected color. This dwarf planet is the second brightest object in the entire Kuiper Belt, outshone only by Pluto itself. For years, it was studied as a solitary, brilliant point of reddish light, a frozen world seemingly simple in its solitude. Its brightness suggested a surface covered in highly reflective ices, but its persistent red hue was a puzzle waiting to be solved. That color is the signature of something fascinating and complex, tholins. These are not simple compounds. They are large, complex organic molecules that form when simpler ices like methane are bombarded by ultraviolet radiation from the sun and cosmic rays over billions of years. Think of it as a sunburn on a cosmic scale, a slow chemical tan that transforms a world's surface into a reddish-brown organic sludge. Makemake, it seemed, was a world coated in the primordial building blocks of life, frozen in time at the edge of the solar system. Yet for all its visual prominence, Makemake appeared strangely barren in another way. Unlike Pluto, which has a complex, hazy atmosphere, or even Eris, Makemake showed no signs of holding onto a significant gaseous shroud. This was perplexing, given its size and the presence of surface methane ice that could, in theory, sublimate into an atmosphere as it neared the sun. The answer likely lies in its cold, stubborn nature. Makemake's orbit keeps it consistently far from the sun's meager warmth, so any gases that might try to form an atmosphere simply freeze back onto the surface, creating a world locked in a deep, silent frost. But the story of Makemake took a dramatic turn in 2016. After a decade of searching, the Hubble Space Telescope spotted a tiny, faint companion orbiting it. This moon, nicknamed MK2, was incredibly dim and small, a mere speck dancing around the bright dwarf planet. The discovery of this moon was a scientific bonanza. By observing the moon's orbit, astronomers could finally calculate Makemake's mass with precision, revealing it to be less dense than previously thought, likely a mix of rock and ice. Furthermore, the moon's existence itself is a clue. Moons around these distant worlds often form from colossal impacts, much like our own moon. MK2 suggests that Makemake, for all its serene and colorful appearance, also has a violent past, a history of collision and chaos that left it with a silent, dark companion. It reminds us that even the brightest and most seemingly simple points of light in the darkness hold layered stories of formation, transformation, and cosmic violence. Makemake's dark moon hinted at a hidden history, but the next object on our list presents a mystery unfolding in real time, one that defies the fundamental laws governing rings and moons. Quaoar, pronounced Quaoar, is a substantial dwarf planet about half the size of Pluto, discovered in 2002. For years, it was known as a fairly standard Kuiper Belt citizen, accompanied by a small moon named Quaoar. But in 2022, astronomers aimed the powerful James Webb and other telescopes at Quaoar during a rare event, a stellar occultation, where it passed in front of a distant star. As they watched the star's light wink out and then return, they expected a simple profile of Quaoar itself. Instead, they saw something impossible. The starlight flickered not once, but twice, revealing a thin, dense ring system encircling Quaoar. This discovery alone was exciting, but the location of this ring sent shockwaves through the astronomy community. Every ring system we know, from the magnificent belts of Saturn to the faint arcs around Jupiter, exists inside a critical boundary called the Roche limit. This is the distance from a planet where its tidal gravitational forces are so strong they will tear apart any large, solid object that ventures too close. Inside this limit, material cannot coalesce into a moon. It can only exist as a ring of debris. Outside the Roche limit, however, gravity should allow particles to gently come together, snowballing over time into a solid moon. Quaoar's rings are not inside this limit. They are orbiting far, far outside of it, in a region where every rule of celestial mechanics says they should have clumped together into a moon-like Quaoar billions of years ago. It is as if you threw a handful of sand into the air and it refused to fall, instead perpetually spinning in a perfect, stable circle. This is the profound puzzle of Quaoar. What invisible hand is holding this ring together, preventing nature from taking its course? Scientists are scrambling for answers. Perhaps unseen shepherd moons, too small for our telescopes to detect, are gravitationally herding the ring particles, keeping them in line. Or maybe the particles themselves are not what we think. They could be extraordinarily bouncy and elastic, so that when they collide, they do not stick together but rebound, maintaining the disk. Some even speculate that the cold temperatures out in the Kuiper Belt have created a unique kind of static electricity or other force that counteracts the pull of gravity. Quaoar's impossible ring is a stark reminder that our textbooks are not finished. At the edge of our solar system, the universe is still performing experiments in physics that we do not yet understand. The Kuiper Belt seems to enjoy creating celestial mirrors and opposites. Just as Eris challenged Pluto's status, another world mirrors its very dance with the Sun, but from a shadowed position. This is Orcus, often called the anti-Pluto. The name is perfectly earned. Orcus is nearly the same size as Pluto and, more intriguingly, it is locked in the same orbital resonance with Neptune, completing 2 orbits for every 3 of the ice giants. But here is the cosmic twist. Orcus performs this dance always on the opposite side of the solar system from Pluto. When Pluto is at its closest point to the Sun, Orcus is at its farthest, and vice versa. They are gravitational bookends, forever separated by the Sun's glare, 2 similar worlds performing a synchronized, opposing ballet across the eons. This mirroring suggests they were shaped by the same sweeping gravitational forces during the solar system's youth, yet ended up in perfectly balanced, opposing niches. But Orcus's true claim to strangeness is not its orbital choreography alone. It is the companion it keeps. In 2005, astronomers discovered that Orcus is not alone. It possesses a moon, and not just any moon. Vanth is enormous. While most moons in the Kuiper Belt are tiny specks compared to their parents, Vanth is estimated to be about 1/3 the diameter of Orcus itself. This is a binary system in the truest sense, a pair of worlds locked in a mutual gravitational embrace, more like a double planet than a primary and a mere satellite. The sheer size of Vanth screams a violent origin story. It is far too large to have been gently captured by Orcus's gravity. The leading theory is a cataclysm, a colossal impact in the ancient Kuiper Belt that shattered a proto-Orcus, with the largest fragment reforming as Orcus and the second largest becoming Vanth. This would make their relationship more akin to the Earth and its moon, born from a single, shattering event. Their surface compositions add another layer of mystery. Orcus appears bright, coated in water ice, while Vanth is significantly darker, its surface possibly covered in the same complex, reddish tholins we saw on Makemake. This stark contrast hints that the impact may have blasted away Orcus's ancient, dark crust, revealing brighter subsurface ice, while Vanth formed from a mix of deeper, darker material. Together, Orcus and Vanth are a frozen fossil of a single, world-shattering moment, a binary testament to the chaos from which even the most balanced and mirrored orbits were born. The binary dance of Orcus and Vanth reveals a history of collisions, but some giants of the Kuiper Belt prefer a quieter, more solitary existence. Among these are 2 colossal worlds that, for years, held a unique and almost anonymous status, the largest unnamed objects in our solar system. The first is known only by its discovery designation, 2002 MS4. This is a behemoth, estimated to be roughly the size of the Dwarf planet Ceres from the asteroid-belt, making it one of the largest known bodies in the entire Kuiper Belt. Yet it is a world of profound stillness. Unlike the frantic, egg-shaped spin of Haumea, 2002 MS4 rotates with a slow, solemn grace. Its day is a leisurely 9 hours long, a stately turn that suggests a calm and undisturbed history, possibly without the giant, moon-forming impacts that shaped so many of its neighbors. It is a silent, dark giant, a reminder that not all kings need a crown or even a name to command presence in the frozen dark. Its companion in anonymity was, until very recently, an even more intriguing character, 2007 OR10. For years, astronomers nicknamed it Snow White, a playful moniker that proved to be wonderfully ironic. Snow White is not bright and pristine. Instead, it is one of the reddest objects ever found in the outer solar system, a deep, rusty hue that blankets its surface. This intense color is another signature of tholins, those complex organic molecules, but on Snow White they are particularly abundant, suggesting its surface ices are rich in methane that has been cooked by radiation over billions of years. Yet the red color is not uniform. Detailed observations revealed mysterious dark patches near its equator, areas where the reddish sludge seems to be absent, exposing something darker and perhaps fresher beneath. This hints at a world with a complex geological history, where processes like cryovolcanism, the eruption of watery, slush, or other ices, might have resurfaced parts of this distant globe. Even more tantalizing is the evidence that Snow White might, at times, hold onto a whisper-thin atmosphere of methane gas. When it swings slightly closer to the Sun on its elongated orbit, the feeble warmth could cause some of its surface methane ice to sublimate, creating a temporary, tenuous shroud before it freezes back out as it recedes into the cold. For over a decade, Snow White held the title of the largest unnamed world in our solar system, a vivid red giant hiding in plain sight, its very anonymity underscoring how much we have yet to learn about our own cosmic backyard. Its recent official naming, Gong Gong, after a Chinese water god, finally gave it an identity, but its mysteries remain fully intact. The existence of these unnamed giants, one slow and dark, the other red and dynamic, screams a simple, profound truth. We have mapped planets orbiting distant stars, yet right here, in our own celestial neighborhood, worlds larger than some countries drifted for years without a formal name. What other silent giants are still waiting, unseen, in the endless black beyond Neptune? While the unnamed giants turn with a stately pace, the Kuiper Belt also harbors worlds spinning on the very edge of stability. Varuna is a cosmic whirligig, a dark, red world that completes a full rotation in just about 6.3 hours. This is a breathtaking speed for an object its size, a frantic dance that has almost certainly stretched it into a distinct, elongated shape, much like Haumea. If you could stand on its surface, the horizon would whip by in a dizzying blur, day and night cycling in a frantic, 6-hour rhythm. This rapid spin is a powerful clue to its history. Such extreme rotation is often the result of a colossal impact, a glancing blow in the ancient solar system that set the world tumbling like a struck top. Yet Varuna presents a contrasting portrait. Its surface is not bright and icy, but dark and deeply red, coated in the same complex tholins we see on Makemake and Snow White. This suggests an ancient surface, one that has been baked by cosmic radiation for billions of years without significant refreshment from geological activity. This combination is fascinating, a world shaped by a violent, energetic event, yet now cloaked in the darkest, most primordial of materials. Varuna is classified as a classical Kuiper Belt object, meaning its orbit is relatively circular and close in, not dramatically scattered by Neptune's gravity. This makes it a potential time capsule, a primordial building block of the solar system that has remained in its original neighborhood, relatively undisturbed since the dawn of the planets. It is a frozen relic from the construction phase, its frantic spin a permanent record of the chaotic collisions that built our cosmic home, while its dark red crust is the untouched paint of eons. In Varuna, we see the raw, unvarnished aftermath of creation, a world forever spinning from an ancient strike, wearing the oldest colors in the solar system. The dark red spin of Varuna speaks of ancient collisions, but our next destination is a wanderer caught between two worlds. Ixion is an enigma, a celestial hybrid that defies easy classification. It is what astronomers call a centaur, a class of objects with unstable orbits that travel between Jupiter and Neptune, often crossing the paths of the giant planets. But Ixion's story is deeply tied to the realm we are exploring, for it is believed to be a refugee, a trans-Neptunian object that was not content to stay in the frozen dark. Its current orbit is a precarious dance that actually crosses inside Neptune's own path around the Sun. This makes its future uncertain, as the relentless gravitational tug of the ice giant will inevitably perturb its trajectory, possibly hurling it inward toward the other giant planets or ejecting it from the solar system entirely in a cosmic game of pinball. Ixion itself is a substantial world, roughly the size of the large asteroid Vesta, and its surface presents a moderately red hue. This color, again pointing to the presence of tholins, suggests it spent a long time in the outer solar system, baking under the radiation of deep space before its journey inward began. And that is the central mystery of Ixion. Where did it truly come from? The leading theory is that it formed as a classical Kuiper Belt object, a peaceful resident of that distant disk, until a gravitational encounter with Neptune, perhaps billions of years ago, sent it careening inward onto its current chaotic path. It would be a scattered disk object that never quite left the neighborhood, but there is another, more intriguing possibility. Some scientists speculate that Ixion and objects like it might represent an entirely different population altogether. They could be remnants from the region between the giant planets, material that never coalesced into a proper world, or even visitors from the Oort cloud, the vast spherical shell of icy bodies that surrounds our solar system. Ixion, then, is more than just a single strange object. It is a living fossil of dynamical chaos, a captured moment in the gravitational restructuring of our solar system. Its reddish face tells of a cold origin, while its reckless path speaks of a violent displacement. It is a bridge between the stable, classical Kuiper Belt and the untamed frontier of the scattered disk, a reminder that the borders in our solar system are not fixed, but are constantly shifting under the silent influence of gravity's long arm. Ixion's chaotic path shows us a solar system in motion, but some worlds seem content to hide in the deepest, darkest quiet, far beyond the scattered disk. At a staggering 90 astronomical units from the Sun, drifts a world known only by a nickname, DeeDee. Its official designation is a string of numbers and letters, 2014 UZ224, but the story of its discovery is far more compelling than its name. DeeDee was not found by a telescope hunting for planets, but by an instrument designed to probe the very fabric of the cosmos. It was spotted by the Dark Energy Survey, a project whose primary mission is to map distant galaxies and understand the mysterious force accelerating the expansion of the universe. In the midst of staring into the deepest abyss of space and time, this survey caught a faint, slow-moving speck in our own celestial backyard. That fact alone is a profound revelation. It means our most powerful tools for observing the universe are now sensitive enough to pick up incredibly dim, incredibly slow objects right here at home, objects that would have been utterly invisible just a decade ago. So what did they find? DeeDee is a dark world, likely over 600 miles in diameter, which would make it about 2/3 the size of the Dwarf planet Ceres. But its true significance lies not in its size, but in its location and what it represents. At its incredible distance, sunlight is almost 9,000 times weaker than it is here on Earth. The temperature on its surface is barely a whisper above absolute zero, a place where even gases like nitrogen freeze solid into rock-hard ice. This world is not just far away, it is in a state of suspended animation, a fossil preserved in the deepest freezer imaginable. DeeDee's existence is a critical data point. For every one of these dark, distant worlds we manage to detect, astronomers estimate there are hundreds, perhaps thousands, more just like it, too faint for our current telescopes to see. It is a single shadow glimpsed in a vast, dark forest, proving that the population of the outer solar system is far more numerous and far more spread out than our earlier census suggested. DeeDee is a sentinel of the true scale of our solar system, a dark and distant proof that our neighborhood extends into a realm of cold, silent giants we are only beginning to sense. DeeDee is a shadow in the deep freeze, but some objects follow orbits so extreme they seem to trace the signature of a hidden architect. This brings us to a world nicknamed the Goblin. Its official designation is a string of numbers, 2015 TG387, but its informal name is a perfect fit for its elusive, almost ghostly nature. The Goblin was discovered during a Halloween time search, and its orbit is truly something out of a cosmic horror story. It takes an astonishing 40,000 years to complete a single journey around the Sun. But the true strangeness is not its vast orbital period, it is the shape of that path. At its closest approach to the Sun, its perihelion, the Goblin is still a staggering 65 astronomical units away. That is 65 times the distance from Earth to the Sun, a point far beyond Pluto and even beyond the main Kuiper Belt. It never comes anywhere near the giant planets. This fact is the heart of the mystery. An orbit like this should not exist in an empty solar system. Normally, the gravity of Neptune and the other giants would have either pulled such an object inward long ago, or flung it out into interstellar space entirely. The Goblin, like Sedna before it, exists in a gravitational desert, too far out to be easily disturbed by the known planets, yet somehow locked into this incredibly elongated track. So what invisible force is holding it on this specific, extreme path? The answer, according to a growing number of astronomers, points to a single, staggering possibility: a massive, undiscovered planet. This hypothetical world, often called Planet 9, would be up to 10 times the mass of Earth, orbiting hundreds of times farther from the Sun than we are. Its immense gravitational pull, acting over billions of years, could be shepherding objects like the Goblin and Sedna into these strange, clustered orbits, herding them like a cosmic shepherd. The Goblin did not just add another data point, it was a crucial piece of evidence. When scientists plotted its orbit, along with those of Sedna and a handful of other extreme objects, they noticed something uncanny. Their elongated paths were not just randomly oriented in space. Their closest approaches to the Sun, their perihelia, all clustered in roughly the same region of the sky, and their orbits were tilted in a similar direction. This clustering is astronomically significant. It is as if you dropped a handful of pencils on a table and they all landed pointing toward the same corner. The odds of that happening by pure chance are vanishingly small. Something must be organizing them. The Goblin's discovery strengthened this statistical signal, making the case for Planet 9 more compelling than ever. It is not proof, but it is the strongest indirect evidence we have that a true giant, a phantom planet, may be lurking in the perpetual twilight beyond our sight, its gravity writing its name in the paths of these distant, icy messengers. The search for Planet 9 paints a picture of hidden giants, but not every stranger in the Kuiper Belt is a native. Some are interlopers, cosmic refugees from a warmer, rockier past. 2004 EW95 is one such exile, and its presence in the frozen dark is nothing short of a crime scene. When astronomers first studied its spectrum, the pattern of light reflecting off its surface, they expected to see the familiar signature of water ice and tholins common to its neighbors. Instead, they saw something impossible. The data revealed the clear fingerprints of carbon, complex organic compounds, and silicate minerals. This is the hallmark of a C-type, or carbonaceous, asteroid, the dark, primitive building blocks common in the asteroid-belt between Mars and Jupiter. Finding one of these in the Kuiper Belt is like discovering a palm tree growing in the Arctic. It simply does not belong there. The environment where it formed and the environment where it now resides are cosmically opposite. So how did a dark, carbon-rich rock from the inner solar system end up stranded over 4 billion miles away in a realm of pristine ice? The answer lies in the solar system's most violent era, the period of planetary migration known as the Nice Model. In this chaotic reshuffling billions of years ago, the giant planets, Jupiter, Saturn, Uranus, and Neptune, did not form in their current positions. They migrated, drifting inward and outward like giants rearranging furniture in a cosmic room. This gravitational turmoil was catastrophic for the smaller bodies around them. As the giants moved, their immense gravity acted like a slingshot, hurling countless objects in all directions. 2004 EW95 was likely one of those unfortunate victims. It began its life as a rocky asteroid in the inner solar system, perhaps even closer to the Sun than Mars. Then, during the Great Migration, a close encounter with a giant planet, most likely Jupiter, gave it a gravitational kick of unimaginable force. This kick sent it on a billion-year journey outward, past the orbits of all the planets, until it finally found a precarious, temporary home in the distant Kuiper Belt. It did not gently drift there, it was violently evicted. Today, it is a fossil of that ancient turmoil, a piece of the inner solar system's bedrock now trapped in the deep freeze, its dark surface absorbing what little sunlight reaches it, making it one of the darkest objects known in that region. Its existence is direct, physical proof of the solar system's turbulent youth, a piece of evidence flung to the farthest reaches of the courtroom. The exile of rocky asteroids is a testament to ancient chaos, but one object offers a glimpse of the quiet moments before that storm. Arrokoth, formerly nicknamed Ultima Thule, is a time capsule. It was the second target of the New Horizons spacecraft after its historic Pluto flyby, and what it revealed was not a complex, active world, but something perhaps more valuable, a fossil frozen in the very act of formation. As the probe's images resolved from a blurry pixel into a clear shape, scientists gasped. It was not a sphere, it was a cosmic snowman, two distinct lobes gently touching in a permanent embrace. This is what astronomers call a contact binary, two separate objects that formed independently in the early solar nebula and then drifted together so slowly, so gently, that they simply kissed and stuck. Think of two fluffy snowballs in a vacuum, colliding at walking speed and merging into a single, lumpy figure. That gentle merger is the key to everything. Arrokoth's two lobes, named Wenu and Wio, are each about the size of a major city, and their connection is seamless. There is no giant impact crater, no shattered debris field. This tells us their meeting was a peaceful, almost sleepy event, occurring in an era when the solar system was still a vast, calm disk of dust and ice, before the giant planet stirred and began hurling objects across the void. Its surface is a pristine page from that ancient story. It is remarkably smooth, with very few craters. This lack of scars means it has spent 4.5 billion years in a cosmic quiet zone, the cold, classical Kuiper Belt, avoiding the violent collisions that battered so many other worlds. Its color is a deep, uniform red, the classic hue of tholins that have been irradiating its surface, methane ice, since the beginning. But here, the red is not patchy or disturbed, it is a perfect, unblemished coat. Arrokoth is not a fully formed planetesimal, it is the step before. It is two of the very first building blocks, the primordial planetesimals, that gently found each other and stuck. Studying it is like looking at a pile of Legos that have just been snapped together, exactly as they were when a child first assembled them, rather than looking at the finished, complex castle. It provides our clearest, most direct snapshot of the processes that built every planet, from Earth to Neptune. In Arrokoth's two-lobed, reddish form, we are staring at the infant solar system, preserved in the deepest freezer of space, a silent snowman holding the secret of how worlds begin. Arrokoth's gentle kiss shows the calm before the storm, but the outer solar system also holds a record of the tempest itself. This brings us to the chaotic realm of the scattered disk and its pioneer, 1996 TL66. Discovered over a quarter-century ago, this object was a landmark. It was not just another Kuiper Belt object, it was something entirely new. The first identified member of a population we now know is vast and wild. Its orbit was the giveaway, a path so dramatically stretched and tilted it stood out like a scream in a library. While classical Kuiper Belt objects like Arrokoth circle the Sun on relatively calm, flat orbits, 1996 TL66 travels on a highly eccentric and inclined journey. Its orbit is a massive ellipse, swinging from within Neptune's reach at its closest approach to the Sun, all the way out to a distant, frozen aphelion. Even more telling, its orbit is tilted sharply relative to the plane of the solar system. This is not the signature of a quiet, primordial object that formed in place. This is the signature of violence, of a world that has been gravitationally assaulted and flung onto a wild new path. The discovery of this object and others like it revealed a critical truth: the Kuiper Belt is not one monolithic, peaceful region. It has a dynamically hot population, a sea of objects that have been violently stirred up. The prime suspect for this cosmic disturbance is Neptune. The theory is compelling. Billions of years ago, as Neptune migrated outward to its current orbit, its immense gravity plowed through the primordial disk of icy bodies. Some of those objects were captured into stable resonances, like Pluto. But countless others were not so lucky. They received a gravitational slingshot, a kick that sent them careening onto these highly eccentric and inclined orbits, scattering them like billiard balls. This created the scattered disk, a vast, diffuse cloud of icy worlds on chaotic paths that extend hundreds of astronomical units from the Sun. 1996 TL66 was our first clear look at this population. It proved that Neptune's influence did not end at its orbital boundary. Its gravitational reach shaped the entire outer solar system, creating a legacy of chaos that persists to this day. Every scattered disk object we find is a testament to that ancient migration, a frozen refugee from a time when the giant planets rearranged the furniture of the solar system with catastrophic force. The scattered disk tells a story of exile, but not every object was thrown into chaos. Some found a stable rhythm with the giant that rules their realm. 2003 VS2 is a perfect example of a cosmic dancer known as a Plutino. This is not a nickname for a small Pluto, but a formal classification for objects locked in the same gravitational waltz as Pluto itself. A Plutino is a trans-Neptunian object in a 2 to 3 orbital resonance with Neptune. For every 2 orbits a Plutino makes around the Sun, Neptune completes exactly 3. This creates a stable, repeating pattern that prevents close encounters and violent ejections. It is a gravitational harmony, a celestial agreement that has persisted for billions of years. 2003 VS2 follows this precise rhythm, tracing an orbit that, while still somewhat eccentric and tilted, is protected by this mathematical synchrony. It will never get too close to Neptune, because every time it approaches the ice giant's orbital path, Neptune is always on the opposite side of the Sun, their motions perfectly timed to avoid catastrophe. This orbital stability allows us to study Plutinos as a coherent population, a family of worlds shaped by the same gentle, persistent hand. Physically, 2003 VS2 embodies the typical traits of this family. It is a moderately sized world, likely around 400 miles in diameter. Observations strongly suggest it is not alone. Like many Plutinos, it appears to be a binary system, accompanied by a small moon that orbits it. This pairing is another clue to their formation, as such moons often result from gentle collisions or gravitational captures within the stable environment of the resonance. Furthermore, light curve studies indicate it has a relatively rapid rotation, spinning once every several hours. This quick spin, common among these icy bodies, hints at a past shaped by collisions, even within their protected orbits. 2003 VS2, then, is more than just another distant rock. It is a testament to the organizing power of gravity. While the scattered disk is a monument to chaos, the Plutinos are a monument to order, a vast ensemble of worlds all dancing to the same ancient tune conducted by Neptune. Their orbits a permanent record of the solar system's transition from violent turmoil to stable, predictable rhythm. Gravity's organizing power creates stable orbits, but it cannot explain a world that seems to be made of frozen foam. 2002 UX25 presents a physical paradox that defies our understanding of how these distant worlds are built. This mid-sized Kuiper Belt object, roughly 400 miles across, should be a fairly dense chunk of rock and ice. Yet when astronomers measured its mass by observing its tiny moon, they uncovered a baffling truth. The density of 2002 UX25 is less than that of water ice. This is a staggering fact. Think of dropping this entire world into a vast, cosmic ocean. It would not sink like a stone, it would float. This simple measurement forces a complete rethinking of what this object, and perhaps many like it, actually is. A solid ball of pure water ice would have a density just under 1 gram per cubic centimeter. 2002 UX25's density is significantly lower, around 0.8. So what is it made of? The leading explanation is porosity. This world is not a solid sphere, it is a cosmic rubble pile, a collection of icy boulders and chunks loosely held together by their own meager gravity, with vast gaps and caverns in between. Imagine a gigantic, dirty snowball that was never compacted, a fragile structure with more empty space than solid material. This porous, fragile nature suggests it was never heated enough or subjected to enough pressure to collapse into a denser, more solid body. It is a relic of the gentlest possible assembly, a world that came together from smaller pieces so slowly and peacefully that they never fully packed down. But porosity alone might not tell the whole story. Its composition could also be unusual, perhaps containing a much higher fraction of lighter ices like methane or nitrogen frozen solid, mixed in with the rock, creating an overall less dense mixture. Either possibility presents a profound challenge. Our models of how mid-sized objects form through collisions typically predict denser, more consolidated bodies. A catastrophic impact would either shatter a porous world completely or compress it, heating the material and driving out the voids. The existence of such a low-density object suggests that a significant population of these Kuiper Belt worlds may have avoided any major, heating collisions over the entire 4.5 billion-year history of the solar system. They are not the hardened survivors of a violent construction zone, but the untouched, fragile monuments to a quieter, gentler accretion. 2002 UX-25 floats as a ghost of that forgotten process, a delicate world of ice and emptiness, proving that some of the solar system's ancient building blocks were never forged in fire, but whispered together in the cold, dark silence. While some worlds are porous or violently scattered, others have remained in serene, undisturbed orbits since the very beginning. 2002, a W197, is a perfect example of what astronomers call a classical cold Kuiper Belt object. This classification is not about temperature, but about temperament. It describes an object on a nearly circular, flat orbit that has never been gravitationally stirred up by Neptune. Think of it as a peaceful resident of a quiet suburban neighborhood, one that has lived in the same house for 4.5 billion years, never having been evicted or sent on a chaotic journey. This orbital stability makes it a prime candidate for a pristine relic, a frozen time capsule from the solar system's protoplanetary disk. In terms of size, it is a giant among these quiet neighbors, estimated to be over 500 miles in diameter. That makes it larger than many of the more famous objects we have discussed, a substantial world that has simply gone about its business in the slow lane for eons. Its physical characteristics match its peaceful history. Unlike the frantic, tumbling spins of Haumea or Varuna, 2002, a W197 rotates with a slow, stately grace. Its day is a leisurely 8 to 9 hours long, a calm and measured turn that suggests it avoided any major, spin-altering collisions. Even its color tells a story of quietude. Most Kuiper Belt objects show some reddish tint from tholins, but 2002, a W197, presents a remarkably neutral, grayish hue. This lack of strong color is significant. The deep reds we see elsewhere are a sunburn, the result of cosmic radiation cooking surface ices over immense timescales. A more neutral color could mean its surface is somehow fresher, perhaps resurfaced by the gentle collapse of its own porous structure or insulated by a different composition. Or it might simply mean that in its quiet, cold orbit, the process of tholin creation has been exceptionally slow. This world is not flashy. It has no impossible rings, no hyper-fast spin, and no wildly eccentric path. Its strangeness lies in its profound normalcy, in being exactly what theorists predicted a primordial planetesimal should be, a large, slow, gray building block that was left behind when the construction of the major planets finished. Studying 2002, a W197 is like finding a single, untouched brick from the foundation of a skyscraper, giving us a baseline, a pure sample of the material from which all the drama and chaos of the outer solar system was built. Its peaceful gray surface is a testament to quiet origins, but the outer solar system also holds worlds that shine with a deceptive familiarity. 2005 FY9 is one of these brilliant enigmas. For a brief time, this object held a unique title. It was the largest known body in the solar system without a formal name, a placeholder for a giant. That changed when it was officially named Makemake, but its original designation still belongs to another world entirely, a different bright object discovered the same year. This second world, still officially known as 2005 FY9, is often considered Makemake's cousin. They are nearly twins in some respects, both ranking among the brightest objects in the Kuiper Belt, reflecting a tremendous amount of sunlight due to surfaces likely coated in fresh, clean ices. Their similar size and luminosity suggest they formed under comparable conditions as massive members of the primordial disk, yet a closer look reveals they are far from identical. While Makemake presents a distinctly reddish hue from its blanket of tholins, 2005 FY9 appears much more neutral, even slightly blue in some measurements. This difference in color is a critical clue. It speaks to the composition of their surface frosts and the history of radiation bombardment they have endured. The reddish color on Makemake implies its methane ice has been cooked by solar and cosmic radiation for eons, transforming into complex organics. The more neutral color of its cousin suggests a different story. Perhaps its surface is dominated by cleaner water ice, or maybe it experiences some form of resurfacing that refreshes its frost, preventing the dark red tholins from accumulating as heavily. This leads to the other great distinction, the question of an atmosphere. Makemake, for all its brightness, shows little evidence of a sustained gaseous shroud. 2005 FY9, however, remains a tantalizing mystery. Some observations have hinted at the possibility of a transient, ultra-thin atmosphere, perhaps of nitrogen, that might appear when it is closest to the Sun in its elongated orbit, only to freeze solid again as it recedes. This would make it more dynamically similar to Pluto, another bright world with a complex, seasonal atmosphere. The existence of these two bright giants, so similar in stature yet different in their details, is a powerful lesson. It tells us that even objects born in the same nursery, of the same basic materials, can evolve down divergent paths. Slight differences in orbit, in rotational tilt, or in internal heat can lead to dramatically different surface chemistries and behaviors over billions of years. They are not copies, but siblings with their own unique personalities, proving that diversity thrives even in the deepest freeze. The spectrum of a world can paint a portrait in light, and for 2007 JJ43, that portrait is a deep, burning crimson. This object holds a rare and extreme distinction. It is one of the reddest bodies ever measured in our entire solar system. Its color is not a gentle rust or a faint pinkish hue, but an intense, almost violent redness that stands out starkly against the black velvet of space. This is not a trick of the light or a superficial stain. It is the direct chemical signature of a surface that has sat utterly undisturbed for eons, subjected to the most relentless weathering process the universe has to offer. The agent of this transformation is cosmic radiation, a constant sleet of high-energy particles streaming from the Sun and distant stars. For billions of years, this radiation has bombarded the simple ices on the surface of 2007 JJ43, primarily methane and nitrogen. This endless barrage shatters the simple molecules and reassembles them into something far more complex, a class of large organic compounds called tholins. Think of it as the universe's oldest, slowest cooking experiment. A layer of pristine white frost is gradually baked and polymerized into a deep red, tar-like sludge, a primordial organic goo that thickens with every passing millennium. The extreme redness of 2007 JJ43 tells us that this process has been running unimpeded for an almost unimaginable length of time. It has experienced no global resurfacing events, no cryovolcanic eruptions to spread fresh, clean ice over its landscape, and likely no giant impacts to churn up its crust and expose new material. It is a perfectly preserved fossil of surface chemistry, a museum piece displaying the unaltered effects of 4.5 billion years of deep space radiation. In its profound redness, we are not just seeing a color, we are seeing time itself, measured in the gradual, inevitable darkening of ice under an endless cosmic rain. The deep red of undisturbed time is one kind of record, but the tilt of an orbit can be an even clearer scar of ancient violence. 1999 CD 158 carries such a scar, written not in color but in angle. This object follows a path dramatically cocked to the side, orbiting the Sun at a steep incline compared to the flat disk where the planets travel. Imagine our solar system as a vast, round dinner plate, with the planets and most asteroids and comets orbiting neatly along its surface. 1999 CD 158 is like a fly buzzing around the plate at a sharp angle, repeatedly diving down through the plane and then soaring back up above it. This high inclination is a profound puzzle. In the calm, spinning disk of gas and dust that gave birth to our planetary system, objects naturally form in that flat plane, their motions averaging out into a shared, orderly rotation. To achieve such a steep tilt, something immense must have grabbed this world and forcefully knocked it off course, like striking a spinning top to send it wobbling on a new axis. The question is, what delivered that blow? The usual suspect, Neptune's gravity, struggles to provide a full explanation. While Neptune can scatter objects outward onto elongated orbits, giving them high eccentricity, it is less efficient at dramatically tilting their orbits to such extreme angles. The force required is more monumental, more sudden. This points to two staggering possibilities from the solar system's deepest past. One is a stellar interloper. In the Sun's infancy, it was born in a crowded stellar nursery, surrounded by other newborn stars. A close pass by one of these sibling stars, its gravity reaching into our protoplanetary disk, could have been the cosmic cue ball that sent a host of icy bodies, including this one, tumbling onto these wildly inclined paths. The other, more contemporary hypothesis brings us back to the ghostly influence of Planet 9. The gravitational shepherding of a distant, massive planet could theoretically explain not just the clustering of orbits, but also their collective tilt, acting over billions of years to twist the paths of these distant objects into a shared, inclined alignment. 1999 CD 158 is more than a single oddity. It is a member of a small club of extreme inclination objects, and together they form a pattern, a fingerprint. That pattern is the real mystery. Are these the random, scattered survivors of a single, catastrophic stellar fly by billions of years ago, or are they the obedient flock of a hidden shepherd we have yet to see? Each highly tilted orbit is a silent witness, and its testimony points to a moment of unimaginable disruption in our solar system's quiet youth. A perfectly circular orbit tilted on its side is a cosmic contradiction, and that is exactly what 2004 XR190 offers. Nicknamed Buffy, this object defies the standard categories with elegant stubbornness. For decades, astronomers understood the outer solar system as a place of clear divisions. You had the classical Kuiper Belt objects on their calm, flat, nearly circular paths, and you had the scattered disk objects on their wild, eccentric, and often highly inclined orbits, flung there by Neptune's gravity. Buffy shatters this simple duality. Its orbit is remarkably circular, a calm ring around the Sun that keeps it at a steady distance. This is the hallmark of a classical object, a peaceful resident that was never violently scattered. Yet, at the same time, Its orbit is cocked at a staggering 47-degree angle to the plane of the solar system. It does not travel within the great disk of planets and debris. It loops high above and far below it, tracing a tilted hoop in space. This combination, a circular yet highly inclined orbit, is astronomically bizarre. Think of it like a hula hoop held at a sharp angle, spinning perfectly around a center point, but never lying flat. Standard models of Neptune's influence simply cannot create this. Neptune's gravitational kicks are fantastic at creating highly elongated, eccentric orbits, or at giving objects a modest tilt, but they struggle mightily to produce an orbit that is both perfectly circular and dramatically inclined. The physics does not add up. A close encounter with a giant planet typically stretches an orbit into an ellipse. It does not leave it circular while simultaneously knocking it sideways. So if Neptune did not do this, what did? Buffy has become a critical test case, a single data point that challenges our entire understanding of the solar system's dynamical history. One compelling theory revisits the great planetary migration. Perhaps during that chaotic reshuffling, Neptune's gravitational influence was not a single, clean event, but a complex series of nudges and resonances. Buffy might have been caught in a special, temporary resonance that pumped up its inclination while preserving the circularity of its path, a delicate gravitational dance that left it permanently tilted. Another, more dramatic possibility involves the same hidden forces suggested by Sedna and the Goblin. Could the distant, shepherding gravity of a massive planet 9 have gradually twisted Buffy's orbit over billions of years, raising its tilt while other effects maintained its circular shape? Or perhaps the answer lies even further back, in the Sun's birth cluster. A close stellar flyby in those first few million years could have given a select group of objects a powerful sideways kick, sending them onto these uniquely tilted paths before the planetary migration even began. Buffy is not just an oddity, it is a key. Its very existence forces astronomers to refine their models, to consider more subtle or more cataclysmic forces at play. It proves that the history written in these icy orbits is not a simple story of scattering, but a layered narrative of resonance, migration, and possibly hidden architects, all recorded in the silent, tilted circle of a single, distant world. If Buffy's tilted circle is a puzzle, then 2008 ST-291 is a whisper from the edge of audibility. This object represents a new frontier in discovery, not of dramatic orbits or strange shapes, but of sheer, profound faintness. It is one of the most distant trans-Neptunian objects ever detected, a dim speck of ancient ice so far from the Sun that catching its reflected light is like spotting a single candle flame from a distance of several thousand miles. Its existence is a triumph of modern astronomy, a target found only because our telescopes and digital sensors have become sensitive enough to see the almost invisible. The key number for 2008 ST-291 is its semi-major axis, the average distance of its elongated orbit from the Sun. That figure is a staggering 550 astronomical units. To put that into a human scale, if the Earth is one step from the Sun, this object's average position is over 500 steps away. At its most distant, it likely drifts well over 1,000 astronomical units into the black, a journey into the raw frontier of our solar system. But why does finding such a faint, faraway speck matter? Because each one is a solitary surveyor's stake, hammered into the void, helping us map the true and vast extent of the scattered disk. For decades, the scattered disk was a theoretical concept, a cloud of icy refugees flung outward by Neptune. Objects like 2008 ST-291 are the hard proof, the actual population census. By discovering more of these incredibly distant bodies, astronomers can begin to answer fundamental questions. How many are there? How is their mass distributed? Does the scattered disk have a sharp outer edge, or does it gradually fade into the even more distant Oort cloud? Every faint point of light, like this one, adds a data point to that map. Furthermore, by studying its orbit, even crudely, scientists can weigh the solar system. The paths of these outermost objects are subtly sculpted by the combined gravity of everything inside their orbits, from the planets to the collective tug of billions of unseen Kuiper Belt objects. Finding more of them and charting their movements allows astronomers to take a cosmic census to estimate the total mass of the scattered disk and the outer solar system as a whole. 2008 ST-291, then, is more than just a record holder for distance. It is a benchmark of our technological reach and a critical pin in a map we are only beginning to draw. Its faint glow is a signal from the outermost outpost, telling us that the kingdom of ice extends far, far further than we ever dared to hope, populated by countless silent giants we have only just begun to see. Far beyond even the most distant scattered disk objects, a faint pink dot redefines the frontier. Our final destination is 2018 VG18, nicknamed Farout, and its name is a simple, powerful statement of fact. When astronomers announced its discovery in December 2018, it shattered a symbolic barrier. This was the first solar system object ever observed while orbiting beyond 100 astronomical units from the Sun. At its discovery distance of about 120 AU, sunlight takes over 16 hours to reach its frozen surface, and the Sun itself would appear as little more than a brilliant star in its perpetually black sky. Its motion across the heavens is almost imperceptibly slow, a glacial drift that perfectly matches its unimaginable distance. This slowness is why it remained hidden for so long, a barely moving speck against the fixed background of stars, requiring the most sensitive surveys to finally catch its crawl. But Farout is more than just a record holder for distance. Its pale, pinkish color, observed through telescopes, is a subtle clue to its nature. That gentle tint strongly suggests a surface coated in water ice, a frosty shell that has been irradiated over eons, possibly beginning the same chemical tanning process that turns other worlds deep red. This hints that despite its extraordinary isolation, it is fundamentally made of the same stuff as its closer-in cousins, a primordial ice dwarf born from the same ancient disk. The profound importance of Farout is not in its individual features, but in its existence. For over a century, we pictured the solar system ending with Pluto. Then we pushed the boundary to the Kuiper Belt, then to the scattered disk with objects like Sedna. Farout proved that our own cosmic backyard extends into a realm we had only theorized. Its discovery was a direct challenge, a declaration that the vast volume of space between 100 and 2,000 astronomical units is not empty. It is populated, and if we found one object there with our current technology, it logically implies there are hundreds, perhaps thousands, more like it, each a frozen sentinel in the dark. Farout is a milestone, a signpost planted in the void. It tells us that every time we build a more powerful telescope, every time we develop a more sensitive camera, we will push this frontier further back. It promises that the next Farout, the next record breaker, is already out there, drifting silently in the cold, waiting for our gaze to finally fall upon it. This pinkish world concludes our list of 25, but But it does not conclude the story. It is an opening chapter. Farout's lonely glow is a beacon from the dark, but it is not the only one. The orbits of these distant wanderers, from Sedna to the Goblin to Buffy, are not random. They are a message, and astronomers have begun to decipher its code. The pattern is subtle but statistically undeniable. When you plot the paths of the most extreme objects, those with orbits so vast they never come near Neptune, a strange alignment emerges. Their elongated orbits are not scattered in all directions like a handful of thrown confetti. Instead, their closest approaches to the Sun, their perihelia, cluster together in the same general region of the sky. Even more telling, the orbits themselves are tilted in a similar direction, as if an invisible hand had gently brushed them into a shared orientation. The probability of this happening by pure chance is astronomically low, less than 0.0002. Something is organizing them. That something, according to the leading hypothesis, is a ghost planet. This hypothetical world, dubbed Planet 9, would be a true giant, with a mass up to 10 times that of Earth. It would orbit hundreds, perhaps over 1,000 times farther from the Sun than we do, on a path tilted relative to the rest of the solar system. Its immense gravity, acting over billions of years, would act as a cosmic shepherd, herding these smaller icy bodies into the clustered, tilted orbits we observe today. It is a gravitational signature written across the void. The search for this phantom is now one of astronomy's great quests. Teams are scouring archival data and conducting dedicated surveys with the world's most powerful telescopes, like Subaru in Hawaii. They are not looking for a bright, obvious dot. At such distances, even a giant planet would reflect only the faintest whisper of sunlight, and its motion against the stars would be agonizingly slow. Finding it is like searching for a single, dim coal in a mountain of black velvet, a coal that moves just a few pixels per decade. The potential properties of Planet 9 are as fascinating as the search itself. If it exists, it is likely an ice giant core, a world similar to Uranus or Neptune that was ejected during the solar system's chaotic early migration. Instead of being flung into interstellar space, it was thrown onto a vast, elliptical orbit, where it has silently presided over the outer dark ever since. Its discovery would be a revolution, not merely for adding a new planet to our charts, but for rewriting the story of our solar system's formation. It would confirm that the great planetary migration was even more violent and dramatic than we thought, and it would prove that our solar system's family portrait is still incomplete. More profoundly, it would validate a powerful method of discovery. We would have found a planet not by seeing its light, but by reading its gravitational handwriting in the paths of the tiny, icy worlds it commands. This would open a new chapter in astronomy, proving that even the darkest, most distant rulers can be found by the trails they leave in the movements of their subjects. The hunt continues, a silent vigil in the data streams of telescopes, waiting for that one faint point of light to finally step out of the shadows and into history. From impossible rings to cosmic snowmen, the 25 strangest trans-Neptunian objects have revealed a frontier of breathtaking diversity. Each one is a unique chapter in the solar system's untold history, a frozen fossil that challenges our neatest theories. We have seen worlds stretched by their own frantic spins, rings that defy the laws of moon formation, and dark asteroids exiled from the inner solar system, now stranded in the deep freeze. We have met binary pairs locked in eternal dances and solitary sentinels on orbits so vast they hint at hidden giants. Every single oddity, from the deep red of ancient radiation to the pristine gray of untouched beginnings forces us to revise our models. The story of our cosmic neighborhood is not one of quiet, orderly formation, but a dramatic epic of migration, collision, and gravitational chaos, written in ice and preserved in the dark. This is the profound lesson of the Kuiper Belt and the scattered disk. Our solar system was built in a frenzy, and its most unaltered witnesses are these distant, silent worlds. Yet this is only the beginning of the census. The next great leap in understanding this final frontier is already underway. In the coming years, the Vera C. Rubin Observatory, with its immense mirror and giant camera, will begin a decade-long survey of the entire southern sky. It will not look for these objects one by one. It will watch the whole sky night after night, catching the faint, slow glides of countless distant dots. This monumental project is expected to discover not dozens, but tens of thousands of new trans-Neptunian objects. We will move from studying rare curiosities to understanding entire populations, mapping the full architecture of the solar system's outer reaches with statistical power we have never possessed. We will find more rings that break the rules, more exiles from other zones, and undoubtedly, worlds with strangeness we cannot yet imagine. Each new discovery will be another piece of the puzzle, helping us decipher the true story of how our planetary system was assembled from the primordial cloud. The frontier is not a static line on a map, it is an expanding horizon of knowledge, so stay curious. The next time you look up at the night sky, remember that beyond the familiar planets, in the profound and silent dark, our solar system is still full of secrets waiting to be found. The greatest discoveries in our own cosmic backyard are still to come.